All right, we're going to finish our conversation we were having with conservation of energy. In the last example, we had discussed the rocket that was flying up. The rocket had, trying to get the pins to pull up here so I can write this for you. We had this rocket that had this flame that was coming out of it. And we'll draw a quick little picture here of the rocket. There's some wings coming off it. There we go. Now, there were some different stages of this rocket. The first stage was while the engine was firing, and it had some height that it had gotten to, and that was 21 meters. After that, it went an additional 700 and some odd plus feet, or meters, 700 more meters. Well, there's a couple stages. At this point, it had all this kinetic energy. And over the next 700 meters, this available kinetic energy, because it was going so fast, was slowly being changed into potential energy. So lots of kinetic energy, losing kinetic energy, but gaining potential energy as it goes up. Well, what this takes us to here then is at the top, it was all potential energy because it had no velocity, but it had lots of height. So up here is all the potential energy that we had at the beginning. What we find out then is that the change in the kinetic energy is going to be equal to the change in potential energy. In essence, as it loses kinetic energy, almost all of it goes into potential energy. We're going to talk about where some of this other energy goes. Some of that other energy is called internal energy, and we'll talk about that in days to come. But the change in kinetic energy is the change, once again this triangle means change, in the 1/2 mv squared, or the kinetic energy. The mass isn't changing, so what's changing? Well, it's losing speed. As it loses speed, it's gaining height. The height is changing. What we find out is, as we've learned, mass can be divided out on both sides. And there gives us this relationship here. And this relationship, or this equation, can be used to find what is going to be the change in height as we go on. Well, here's a practice problem. We have up here, I'm going to write it up here for us, the change in 1/2 v squared, because the masses cancel out, is equal to the change in gravity in height. So what we can say is, for example, this 500 kilogram car, but notice, mass is irrelevant, so this is just an extra information that's not even really necessary to solve our problems here. Is let go on a coaster from a starting height of 50 meters. So we know that it's going to start at 50 meters, so yi is 50 meters. Find its velocity at the following heights, right, at 0 meters. So now it's gone, the change up here, in this case, the change in GH is when it goes from 50 meters to 0 meters. So let's set up our equation. The change, right, the change in velocity here is equal to the change in gravity times height. Well, initially, we have the change in height is going to be, what this really comes down to then is, sorry, I had to think there for a second, is how much does the height change? And that's what we're going to put in here. Well, it goes from 50 meters to 0. So this is going to be 9.8 times 50. And then over here, we're going to solve for the velocity. I have 1/2 velocity squared. Well, multiply by 2. And we get the velocity squared is equal to, let's get the calculator out real quick. And the velocity squared is 980. Well, if we square root both sides, we get an answer of 31.3 meters per second it would be going. So at the bottom of the hill. So what we did, again, is the first thing we did is we said, find the change in height. and we said that was going to be from 50 to 0. So we put 50 in here for height. And then it's just a matter of solving for v. In this case, the change in height is going to be from 50 to 10. So my change in height is 40. Let's go ahead and take a second here and let you try to find that answer. What I'm going to do here now is I'm simply going to erase the stuff that we're going to change here. The only thing that's going to change here is our height. This number is going to change, and this number is going to change. The change in height is 40, so now it's just an algebra problem. And we get 9.8 times 40 times 2. And then we take this, that gives us 784. If we take the square root of that, we find out that the change in velocity is 28 meters per second. That means at the 10 meter mark, it's going 28 meters per second. I want you to find out what it would be when it gets down to the 25 meter mark. Tomorrow in class, we'll talk about this internal energy. Have a good day.